Hi students, this is Mr. Yao. In the previous lesson, we have learned about factor by special cases. In this lesson, we're going to continue to learn more about that, but let's quickly look back on what we learned in the previous lesson, which is about perfect squares. Here they are. We can have a square and a b square. In the middle, we either have a 2ab being positive or a 2ab being negative. That would change the sign inside the parentheses, but that's perfect square trinomial being factored. This could actually be helpful for us to actually do mental math. So let's see how that would work. Here you go, mental math, and then how do we actually do this question without using a calculator? The reason we can do this is because, well, 57 being squared, it's actually quite close to another number. 57 is close to 60. And we can easily do 60 squared in our head. 60 squared, just 6 squared, and then putting 2 extra zeros on the end, which is 3600. Let's see how they're actually related. 57 is 60 minus 3. So by the rule, if we actually want to do 60 minus 3 squared, we would get a 60 squared. We would also get a 3 squared. They're being added. Then we're also in the middle. Well, this basically means our a is a 60, so this is our a, and b is the 3. So in the middle is going to be a negative 2ab. So we're just doing 2 times 60 times 3, and that's being subtracted. Let's see if we can do everything in our head. 60 squared is 3600, and 3 squared is going to be a 9, and then 2 times 3 is a 6 times a 60 is going to be a minus 360. So we would end up with a 3609 minus 360, which is going to be 3249. Yeah, there we go. So that is 57 squared. And that's exactly how we can use that to help us to do things quickly. So now, let's see 73 squared. I'm going to ask you to pause and kind of follow the same thing and try to do everything in your head. Well, you have tried. So 73, in this case, is actually closer to 70. So instead of minusing, we're going to do 70 plus 3 squared. So this is our a, that's our b. We're going to end up with a 70 squared, which is 4900. We're going to end up with a 3 squared, which is a 9. Then in the middle, we have a 2 times 70 times 3. 2 times 3 is a 6 times 70 is a 420. We can actually add all of these few things together. So 4909 plus 420, that is going to be 5329. There you go. So that is 73 squared. If you actually want to practice more, here's some more you can practice. Let's say you can do 61 squared, or you can do maybe 88 squared. Because any number you see is actually kind of close to a 0, and then you just go from there. But then there's more. A squared minus b squared equals a plus b times a minus b. Let's see how that would work. Let's see, we have the number 57 times 63. Well, neither of them is going to be our a or b, because there is actually another number that's close to them. So 57 is 3 away from 60. 63 is also 3 away from 60. So this is actually going to be a 60 minus 3 times a 60 plus 3. There you go. So we're going to use the number right in the middle, especially when that actually is going to be a 10 of a number. So this basically tells our a is going to be 60, our b is going to be 3, and we're doing an a plus b and an a minus b, which is just a squared minus b squared. So this is the same as a 60 squared, subtracting a 3 squared, so 3600 subtracting 9, which is 3, 5, 8, not 8, 9, 1. There you go. That's 57 times 63, so it's now time for you to try 74 times 66. Hopefully you have tried. This time, the number in between them is actually a 70. So 70 plus 4 and a 70 minus 4. So we can do 70 squared minus 4 squared. Because this means our a is 70, our b is a 4. So it's going to be 4900 subtracting 16, which is 4884. Here are two more that you can try. Let's say you are working with 78 times 82. That's one you can try. Or let's say you're working with 45 times 55. There you go. So these are the two that you can keep trying. Now let's move on. In this lesson, the special cases that we're working with are perfect cubes. Unfortunately, there's no easier way, so it is just going to be the two formulas. It's either a cubed plus b cubed or it's a cubed minus b cubed. It's actually easier to look at them together because they are related. So in order to get a cube, you for sure need to have a first power and then a square. First power and a square, a first power and a square, a first power and a square. The thing is, this looks very similar to the perfect square factoring formula. The middle, except, is not minus 2ab or plus 2ab. It's just minus ab plus ab. If you actually try to multiply, you will see all the middle terms are going to cancel each other, and you are just left with a cube and a cube. So if you look at them together, let's see. When it's addition, it's going to be addition in the first parentheses. When it's subtraction, it's subtraction in the first parentheses. So that one just follows. The next sign is the opposite from the first one. So if it's addition in the first parentheses, the next sign is going to be a subtraction. If it's subtraction, the next sign is going to be a plus. At the end, it is always going to be addition. So there you go. So let's have a look. Example 1. In order to do this, we're going to need to identify our A and B. Also, since we need to put our answers in standard form, we might as well make sure the questions start as a standard form. So in example 1, we're going to need to switch the orders first. 216m cubed plus 1. Let's identify our A and B. This 1 is actually just 1 cubed, so our B is just a 1. Our A, in this case, well, m cubed, for sure, each A is going to get an m. Then we actually need to find the cube root of 216. Because this 216 is actually corresponding with a cube, which means it's a cube of a number. And that number is actually a 6. So now we're just going to put everything into the formula. One thing to be careful with is, if, for example, like this A is actually 6m, we are going to need to use parentheses. So A plus B, in this case, it's 6m plus the 1. That's very easy. And then the next sign is going to be the opposite. It's a squared in there, so it's actually 6m, but it's the whole thing being squared. So I'm going to actually use parentheses. And then I'm subtracting. My A is 6m, my B is 1, because I'm subtracting A times B. On the end, I am adding just B squared, which is 1 squared. Okay, now let's actually simplify this. So we have 6m still staying in the front, plus 1. And then the second set of parentheses, 6m being squared, the whole thing being squared is 36m squared. And minus 6m times 1. And then lastly, a plus 1. There you go. That's example 1. Moving on, example 2. N cubed is going to be our A cubed, so our A is n. And this is our B, which is a 3. One thing to be careful, we are not actually taking the middle the sign with A or B, because the sign is going to be taken care of by the formula when we actually later put everything into the formula. So now let's do it. This time is the subtraction, is going to have to use the bottom one. So the first parenthesis is going to follow exactly what the sign is in the question, so it's on minus 3. And the next one, well, since A is just n, B is just 3, we don't have to be special about the squaring. So in this case, it's just n squared plus the second sign is different from the first one. So plus 3n. And then on the end is 3 squared, which is just a 9. And that is example 2. Moving on, still the same thing. Example 3. This time, as you can see, it is already in standard form, but since the question starts with a negative sign, we are going to have to take that out as a GCF. That is one thing a lot of you actually missed on the quiz. So GCF is going to be a -1 or just a negative sign. Let's take it out. And we're left with a negative 27a cubed minus 8. Let's identify our A and B. It's going to be looking a little bit confusing since we are having an A. But just remember we're identifying this a just represents the first term. 27 is cubed of 3, so it's going to be a 3. A cubed, of course, we give 1a here. And b, we're not taking the sign, we're just looking at the number, is 8. That is 2 cubed, so b is 2. Now let's put everything into the parentheses. First set of parentheses is going to be the same sign as the original question. After take out the GCF, we actually have a minus, so it's going to be a 3a minus 2. And then the second set of parentheses, since 3a, two things, we want to make sure we're squaring them together. I'm going to put them inside parentheses and deal with that in the next step. 3a in parentheses being squared. The second sign is different from the first, so it's 3a times 2 being added, and then plus a 2 squared on the end. Don't forget, in this question, we have a GCF that needs to stay in the front, so there is still a negative sign. Last step, I just need to simplify a negative sign, 3a minus 2, and then 3a, the whole thing being squared is a 9a squared, 3a times 2 is a 6a, and on the end, 2 squared is a 4. There you go. That's example 3. Example 4, first, it is not in standard form, so let's move everything around. Negative 8x cubed minus 125, that means we're starting with a negative sign, so we have a GCF of negative 1. Check it out, we're left with 8x cubed plus 125. Now let's identify our a and our b. A is 2x, b is 5. Put everything into the formula. Don't forget the negative sign in the front because that is our GCF. So 2x, follow the same sign as the question inside the first set of parentheses. And then continue, since we have two things, 2x in square, so I need to put them inside parentheses. The second sign is different from the first one, 2x times 5. And lastly, just a 5 squared being added. Don't forget the negative sign in the front. Okay, simplify. 2x plus 5, 2x being squared is 4x squared. And then subtract 10x plus 25. That is example 4. Let's continue. 5 and 6. Now things are getting a little bit more complicated. So, example 5. Well, that one just has a GCF, so it's not too bad. Let's take out the GCF, which is a 3. And we're left with 8x squared cubed minus 27. Identify our a and b. A is 2x, b is 3. So 3 stays in the front as the GCF. Then we have 2x minus 3, since the sign needs to be the same as the question. And then it's 2x being squared again. Then add 2x times the 3. On the end, another 3 squared. Simplify. 3 in the front, 2x minus 3 inside the first parentheses. Then you square the whole thing, 4x squared plus 6x plus 9. That is example 5. Next, example 6. So where things get a bit more complicated. It is to the 9th power. Well, 9 is a cube. I mean, 9 has a 3 in it. So x to the 9th power, if we actually want to identify our a, our b, b is easy, b is just a 3. Our a would have to be x cubed. Reason is, well, when you actually cube an x cubed, you're supposed to multiply the exponents, since this is power rule. And that is going to be x to the 9th power, which means the cube root of x to the 9th power is x cubed. Now let's still do the exact same thing. Inside the first parentheses, using the same sign, so it's x cubed plus 3. Second set of parentheses, we're squaring our x cubed, and then x cubed is being multiplied with a 3, and then on the end, 3 squared. Okay, simplify. X cubed plus 3. X cubed being squared is x to the 6th power. And then we have 3x squared and a 9 on the end. There you go. That's example 6. Example 7 and example 8. Things are getting more complicated. Example 7. Let's first take out a GCF, which is a negative 8. We're left with an 8x to the 6th power, y to the 3rd power, minus 1. So b is very easy to identify. B is just going to be a 1. Our a is a bit more complicated. Well, we need to find the cube root of 8, which is a 2. the cube root of x to the 6th power is x squared. The cube root of y cubed is just a y. There you go. Don't forget the GCF in the front, -8. And then we have 2x squared y minus 1, using the same sign as the original question. Then it gets a little bit more complicated. The whole 2x squared y needs to be squared. And then the second sign is opposite, so it's a plus now. 2x squared y times the 1. On the end is just a 1 squared. Okay, let's simplify. -8 stay in the front. 2x squared y minus 1 there. And then 2x squared y, squaring the whole thing, it is a 4x to the 4th power y squared. And then we have a plus 2x squared y and a plus 1 on the end. There you go. That's example 7. Last one, example 8. Well, the cube is already there, so A is easy to identify, just A looks complicated. A is 2x plus 3y. Our B, well, 343 is actually 7 cubed, so our B is just a 7. Now let's try to put everything into the formula. 2x plus 3y, subtracting a 7. First set of parentheses, kind of fairly straightforward. Second set of parentheses, 2x plus 3y, the whole thing needs to be squared. So 2x plus 3y being squared. And then the second sign needs to be opposite, so plus 2x plus 3y times a 7. On the end is a 7 squared. Now we actually need to simplify the whole thing, especially inside the second parentheses. The first set stays 2x plus 3y minus 7. And then the second set of parentheses, you kind of need to deal with everything separately. So I'm going to do it on the top. This 2x plus 3y being squared, it is the same as 2x plus 3y times another 2x plus 3y. Okay, well, whatever method you want to use, you can do box or you can do the string. Either way, it is going to end up being a 4x squared plus 12xy and then plus a 9y squared. And we still have the extra. 2x times the 7 is a 14x. 3y times the 7 is a 21y. And then another 49 in the end. And there's not exactly any term we can combine, so this is the final answer. And that is example 8. That's everything for this factor special case perfect cube lesson. Thank you.